Let's have a quick run through transformations. Now, as you're probably aware, there are 4 transformations. Translation, when you basically just slide the shape across the surface of the graph, is the easy one. Rotation, I think, is the hardest, where you rotate around a point. Reflection, we need a mirror and we reflect in it. And enlargement, where we basically take a shape and expand every length by the same amount. So have a look at the easy one first, translation. Here we have a translation of A into B. A translation is described by a column vector in the form 3/1, say, 3/1. Every part of the shape is translated 3/1. So it goes 3 along X, 1 up, 3 along X, and 1 up Y. The shape is not altered by the translation. The top of the column vector is X. This is often made a mistake, so let's just remember that. Imagine you have an ordinary coordinate that gets rotated to create a column vector. Just swing this round to be X over Y, and I'm going to put a box around that so that you know it's important, and hopefully we'll remember it. Try not to get them the wrong way round. Reflection. Now, reflection is defined by a line. The most common mirror lines are vertical, say X equals 1, or horizontal, say Y equals 4. See how every point on here has Y equal to 4. So remember that Y equals 4 is horizontal. Get rid of that one. We're going to look at reflection in X equals 1. Points move along a line perpendicular to the mirror line, so right angles to the mirror line. This will move along there, and they travel the same distance behind the mirror as they are in front. So that's 1, 2, 3, 4, 5, goes to 1, 2, 3, 4, goes to here. And this little point down here goes 2 along, and it goes 2 along there. Again, find the position of single points, and then you can draw in the rest. Well, pretty obviously that's where B has gone to, but you can use this point as well if you need to. Be careful. X equals 1 is vertical. I think that's probably the hardest part. Get the mirror line right and you're probably away with reflection. Enlargement. This is the one with the trumpet shape. Well, you might have seen the trumpet shape. Here's enlargement, scale factor 2 with centre of enlargement 0, 0. So we need a centre and we need a scale factor. Lines from the centre of enlargement to the shape. Place points further along these lines. If the scale factor is 2, the points are 2 times further. If the scale factor is 3, the points are 3 times further. So here's our centre of enlargement. We are 1 along 2 up. And so 1 along 2 up would be an enlargement of 2. We've increased this line by 2. Same for the red point. You can measure this if you want, or you can use the 3 along 1 up, 3 along 1 up. This is an enlargement of 2. All of the lengths here are twice the lengths they are here. And as area is length times length, the area of B is 4 times the length of A. An interesting fact. Remember, lines come from the centre of enlargement. You can have negative enlargement. I don't know if that's in your course. And you come back. So a negative scale factor -1 would put this dot here. But I don't think that's in your course. All right. The tricky one. Rotation. Now we're going to look at anti-clockwise rotation by 90 degrees. Centre of rotation 0, 0. So we'll mark that. Centre of rotation, an angle and a direction. 3 things that define a rotation. Drawing direction on the graph will reduce errors. Oh, how many times have people put it in clockwise when it should have been anti-clockwise, etc., etc. And I use an L method on a few points. So the L method I use because it's easier to draw an L than think about a point. So I draw an L to a point. So there's that point there, and sort of mentally maybe, or maybe lightly with the pencil, I draw this line. It's a sort of reverse L actually, isn't it? So this line rotates to here, and this line rotates to here. So I go 1 along and 2 up, 1 up and 2 along. It's a sort of mental rhythm, and there's my point. I've got another point out here. 3 along and 1 up becomes 3 up and 1 along. Another point there. And again, just draw in a few points. A rotation keeps the shape, so we can complete the shape like that. You can use tracing paper. I've never actually used tracing paper, but I know people who have, and they're okay. So let's take a sheet of tracing paper. There's our central point. I'm going to center rotation and angle and direction. I'll draw the direction on the just pencil with a pencil so I don't make a mess and forget which way I'm going. Place the tracing paper over the shape. Keep it still and draw this shape on it, because we're going to rotate it. We're going to rotate it around that point there. So the best thing to do is stick your compass into this point lightly. Don't go through the desk. Then rotate the tracing paper. And we're over here now. This is our little drawing. And we want to get this drawing onto the paper, your exam paper. So again, press your compass not too hard into these corners so you make a little mark on your exam paper like that, and then you remove the tracing paper and draw up the join the dots to form your shape. You could, of course, use the L method and then use tracing paper in order to check it. I'm very pleased to say I get the same answer both times. So there you have it. We don't need past papers just now.